Welcome to the session. Today let us understand about what is a synchronous generator construction and working principle of synchronous generator. What is basically a synchronous generator? So we all know that a machine which generates an AC EMF are known as synchronous generators or alternators. So when we compare the synchronous generators with DC generators, the main difference would be in the DC generator where the field of the DC generator is kept stationary and the armature is made to rotate. But in the case of an alternator, what we do is it's vice versa. The field is rotating and the armature is made stationary. So here in your synchronous generator, there is no commutator or the brushes which were used in DC generator. The slip ring and the brush assembly which were used in the DC voltage or DC generator will not be available in your AC generators. So generally the AC generators or the alternators are used to produce very high voltages and they are installed at modern power stations. So we must understand, when compared to DC generators, when we rotate the field, what are the different advantages? Now, when we rotate the field, we have large AC EMF which is developed in the armature. So as it is stationary, so large space can be provided in order to accommodate large number of conductors and the insulation. Also, the armature gets protected from the mechanical and electrical stress. When it comes to collection, it is easier to collect at very large high voltages from the stationary armatures at also large currents. So here we can eliminate the problem of sparking at the slip rings. Also the field is low inertia circuit and easy to rotate. And also the overall construction becomes simple due to stationary armature. And we require only 2 slip rings for the rotating field. So also the ventilation arrangements can be improved. Now, when it comes to construction of the synchronous generator, we can divide it into 2 parts. One is stator, the other one is rotor. Now what is the stator? Now the stator, we can see here the stator of an alternator. In stator of the alternator, the stator has laminated construction which generally consists of core. Here this is the core, stator core, and the slots to hold the armature winding. We can see here the slots wherein the armature windings have been held. So generally it is built up of special steel stampings. So here in this diagram you can see this is a part of an alternator stator. So stator is also stationary part of the machine or the alternator which will be kept constant or it will not be rotated. Now you can see here the copper conductors, the tooth of the machine and the various slots with an insulated lining winding and the overall stator core. So this is the actual stator of the alternator wherein the laminated and the stator cores have been placed here. Now when it comes to rotor, there are 2 types of the rotors. One is salient pole rotor, salient. The other one is non-salient or smooth cylindrical type rotor. So generally in salient pole rotor, the poles are projected outwards and the field winding is provided on the pole shoe. So these rotors generally have large diameter and small axial lengths. These type of rotors are generally preferred for low speed alternators, where in the cylindrical rotors, when we divide into 4 poles like north, south, north, south, it is in the form of cylindrical in nature and it consists of smooth solid steel cylindrical having number of slots to accommodate the field winding. Here the unslotted portions of the cylindrical act as the poles. So these rotors have a small diameters and a very large axial lengths. These are mechanically strong and generally used for high speed alternators, and they are also called as turbo alternators. So these are the two types of rotors when it comes to construction of your alternator. So hope you understood the construction of alternator.